Okay, so in this case here, we reduce the number of nodes to basically 6. Yeah? So we go from 7,500 to 6 nodes, which is of course a lot easier. Now let's derive the formula for this classification problem. And therefore we're going to define two sets. We're going to define a set D, that is a set of pairs of context center word combinations that are found in the corpus. And we call D prime the pairs that are not found in the corpus. Alright? And we've seen that D prime is typically a lot larger than D. So in terms of a binary classifier, we're going to use the famous sigmoid function, and we have an output z. Z is equal to 1 if the pair is an element of D, and z is equal to 0 if the pair is not an element of D. So an element of D prime. And this is of course the negative sampling. This is the negative sampling. Yeah, so of these we're gonna choose about k, and k is a hyperparameter. So it is to be chosen. Hyperparameter. Yeah. So there's a few options. You can look for a validation set and try to see which k gives you the best results. Or another option is that you choose k between 5 to 20 for a small data set, and from 2 to 5 for a large data set. Yeah. These here are Mikolov et al. Is the author of the paper. Yeah, and that is the suggestion they give. Alright, so here we can write this now as a classifier. Probability that z is 1 is a probability that that pair is an element of D. Whereas the probability of z equals to 0 means the pair is an element of D prime. Now, the sigmoid function in this case, so P z equal to 1 given C and W equals 1 divided by, and then e to the 1 plus e to the minus z, and in our case is 1 divided by 1 plus e to the minus vc transpose vw. This is assuming that we use skip-gram. This is a dot product. So this is my z. So that means that the probability of z equals 0 given c and w is basically, let me just give you a formula here. The 1 minus the sigmoid of z equals the sigmoid of minus z. That's easily to prove. You just calculate it. But basically what we're going to have is we're going to have 1 divided by 1 plus e to the vc transpose vw. So the negative from here becomes a positive here. So now we can merge these two. So the probability of z given contact center word equals, so we're gonna take this one is 1 divided by 1 plus e to the minus vc transpose vw, and this to the power of z. Okay, and then we're going to multiply that with the other one, 1 plus e to the vc transpose vw to the power of 1 minus z. Yeah, if z is equal to 1, yeah, this becomes 0, yeah, and this becomes the sigmoid. And if z is equal to 0, this term disappears, this becomes 1, and you get this term. Yeah, so that works out nicely. So now what we typically do, we have our probability. We're going to calculate the likelihood of the parameters theta. Remember, theta are Vc and Vw, because all of this we do to learn word vector representations. And that is again the product of your pairs, an element of both d and d prime, yeah, of that whole thing here. Yeah. So let me just make this easier. So we have P of Z, CW equals. Yeah, so what we're gonna do is we're gonna replace this with L of theta equals, and then we're gonna put the sum here of the pairs element of D and D prime. Yeah, and then we have this whole thing. That comes behind that product. So this is a likelihood function that we want to maximize. Alright? Now, what we usually do is we take the log of the likelihood, because it transforms this product into a sum. So the log of L of theta, and we call this small L of theta, equals, and then we have a sum of pairs that belong to D, and then we have this here, yeah, so the log of this is Z times that, but Z in this case is 1, yeah, so then we end up with this 1 plus E to the minus Vc transpose Vw, yeah, so basically we have a Z here, but this Z is equal to 1, yeah, plus the sum, and then for the pairs CW that belong to D prime, and in this case Z is 0, so here Z is 1, and here Z is 0. So if we take the log, 1 minus Z comes to the front, yeah, and if Z is 0, this is 1, yeah, and then we keep this. So sorry, I forgot a log here, yeah, so and this also is a log of 1 divided by 1 plus e to the Vc transpose Vw. Alright, so that means that L of theta equals the sum of CW elements of D, yeah, and this here, this is the log of the sigmoid of VC transpose VW, right? Plus, here again a sum over CW that belong to D prime, and here we have the log of the sigma of minus VC transpose VW. Yeah? And let me just take this off here to give us a little bit more space. Yeah. So our final formula is this one here. Yeah. Let me just try to isolate it. Yeah, this is our final formula. And of course now we need to calculate, the LDVC and the LDVW. Now let me come back to how to sample here. K is a hyperparameter. Mikolov has given us this indication in terms of choices for K. But how to sample K? How to sample K? Remember, we want to sample, let's say that K is 5, for example. We want to sample 5 negative examples. And there's a few options. We could use uniform sampling. That means that every word has the same probability of being sampled. And this is not really correct because there's a lot of words that appear more frequently than other words. Yeah? So another option is you look at the frequency of occurrence. Yeah? So you do the number of counts of that word divided by total number of words. Yeah? It's an option, but Mikolov has empirically shown that you get the best results when you take the number of counts to the power of 3/4 and then divided by total number of words. Yeah? So this is just some guidance on how to sample K. Alright, there's another technique that we can use to solve our initial problem, another technique than the negative sampling technique, and that technique is called the hierarchical softmax.